The Eastern European sky seemed calm until a convoy of armored vehicles burst out of the mist. Not tanks, not artillery, but machines on wheels with rotors that can turn water into roadway. Within 10 minutes, the Vistula River, once regarded as a natural wall between NATO and Russia, was transformed into a steel highway wide enough for a Leopard 277 tank to cross. In October 2025, Germany and the United Kingdom signed a €450 million contract for 88 M3 modular bridge systems. On paper, it was a logistics purchase. On the strategic map, it was an earthquake, because from now on, the rivers Russia relied on as shields are becoming gateways. And next, you will see why a single bridge can change Moscow's entire defensive calculus. For nearly a century, Russian defense doctrine rested on a seemingly immutable principle: depth and delay. Rivers such as the Vistula, Oder, and Neisse were not merely geographic boundaries, but strategic allies buying time for artillery redeployment, resupplying logistics, and allowing Moscow to catch its breath between Western offensives. But in October 2025, that principle was shaken. Germany and the United Kingdom, two nations with complex historical ties, signed a €450 million deal to procure 88 M3 modular bridging systems from General Dynamics European Land Systems. 56 systems were allocated to Germany and 32 to the United Kingdom. On paper, this looked like a logistics upgrade. In reality, it marked the opening move of a new concept of deterrence by tempo. An M3 system can be emplaced in under 10 minutes, enabling a 70-ton main battle tank to cross a river without fixed bridges, heavy cranes, or close air support. In contrast, conventional interceptors or precision strikes cost hundreds of thousands to millions of United States dollars per launch. Operating an M3 costs only a fraction of that. This disparity creates the modern paradox. Defense becomes more expensive to sustain as offense becomes cheaper to execute. The M3 flips that arithmetic. Yet the true threat to Moscow is not the steel and pontoons themselves, but the software orchestrating the rhythm of the battlefield. Rapid deployment, synchronized logistics, and tempo-driven operations change the strategic calculus. When tempo becomes the weapon, the defender must either match pace at great expense or accept new vulnerabilities. And what makes the M3 truly frightening to Moscow is not the metal or the wheels, it is the software controlling the battlefield's heartbeat. The M3 answers an age-old battlefield question in the most direct way possible. How do you turn water into road as quickly as humanly feasible? It is not a showcase of exotic engineering, but an intentionally minimal tool built to a single design, creed, modular, mobile, software first. Each module measures about 13.3 meters in length and can float to maneuver like an amphibious vehicle. When coupled together, the modules form a bridge lane exceeding 100 meters, strong enough to carry main battle tanks weighing 70 tons. Small crews and deployment times reported at under 10 minutes for a standard configuration rewrite expectations about the so-called delay in river crossings. Fact check note: technical specifications and exercise figures should be verified against official sources. The true power of the M3 lies not in any single piece of metal, but in how it is woven into a modern combat ecosystem. Before the first module ever touches water, a reconnaissance network has already pushed satellite imagery, hydrographic data, and unmanned aerial vehicle video into a routing algorithm that chooses the optimal crossing point in real time. The command and control system pushes synchronized orders to M3 crews and to protective drone teams, while electronic warfare assets establish temporary cover. The outcome is not a lone bridge, but a near-simultaneous mobile corridor that materializes in step with the operational decision, a shift from mechanical improvisation to systemic orchestration. Variants of the M3 reflect different operational demands: a version optimized for ground maneuver, an enhanced buoyancy model for deeper water, and a digitally integrated model that enables rapid health checks and automated locking procedures. Modularity standardizes maintenance and operation across multinational forces. German, British, or Danish crews can operate the same modules on the same logistics network, shortening readiness cycles and lowering total ownership costs. In employment terms, the M3 unfolds along two principal axes. The first axis is armored maneuver. In offensive scenarios, the M3 permits tanks and combat trains to cross continuous water obstacles, converting a stop into a passing through. The second axis is sustainment and orderly withdrawal. Modular bridging transforms a river from a lethal choke point into a viable supply line, preserving tempo and enabling controlled retrograde moves for frontline units. When the M3 is coupled with reconnaissance drones and electronic warfare, the timeline from detection to crossing compresses from many hours to a handful of minutes, a difference that separates holding a line from battlefield collapse. But the M3 is not a panacea. Its effectiveness presumes accurate intelligence, secure command and control links, and a logistics tail that will service the modules with fuel and spare parts. Cyber attack scenarios, jamming or strikes against logistical nodes can blunt the advantage. Likewise, extreme cold, thick ice, and complex hydrodynamics impose physical limits that software alone cannot erase instantly. Tactically, the value is rarely the single bridging event, it is the network effect. When multiple crossing points are opened simultaneously, the defender is forced to disperse artillery and reaction forces, creating the dilemma: if you must defend every river, you defend none. In psychological and strategic terms, the M3 becomes more than an engineering utility, it is a coercive instrument that imposes on the adversary a choice, and often a mistaken one. Thus, the M3 is both hardware and a conceptual lever. It accelerates decision cycles, compresses operational timelines, and shifts the strategic burden from static defense to dynamic tempo. And when dozens of modular bridges begin to stitch themselves across a theatre map, the adversary realizes that the resource they relied on for decades' time has been taken away. And when a string of bridges auto appears across the map, the opponent understands that what they depended on for decades' time itself has been stolen. Modern war is paid for with a single currency: time. When time shortens, the cost of defense rises. When time can be purchased cheaply, the initiative shifts to the attacker. The M3 and its accompanying ecosystem command and control software, reconnaissance drones, and electronic warfare assets do more than accelerate action. They rewrite the arithmetic of the battlefield. Instead of holding every river crossing tightly, an attacker can open many corridors rapidly at low marginal cost, forcing the defender to disperse forces and consume resources at a higher rate. A simple comparison makes the point. Investing in an M3 network is an upfront cost that buys rapid crossing capability. When operated in coalition, the per-deployment expense falls steeply. By contrast, to blunt numerous potential corridors, the defender must increase pontoons, stockpile combat engineers, and spare artillery, and protect logistics lines, a repeating and growing cost. Over time, the side that invests in mobility and in rapid software updates gains a strategic economic advantage. That advantage is amplified by a software-first approach. Upgrading routing algorithms, deploying anti-jamming patches, or integrating new sensors can be done quickly and at a fraction of the price of new air defense hardware. The effective strategy, therefore, is to invest in the network, not merely in modules, to sustain tempo and adaptability. M3 is not limitless. It requires fuel, spare parts, accurate intelligence, and secure command links. Adversaries can respond with cyber attacks, decoys, or strikes on logistical nodes, but each countermeasure carries its own cost. In a protracted contest, the side with a robust industrial base and an extensive alliance network can push the opponent into a costly spiral. When money and manpower begin to flow the other way, who will be the first to tire? The M3 is not a universal weapon, but within its design envelope, tactical target sets from main battle tanks to convoy trains and for rivers of moderate depth to medium watercourses, it is the most effective tool to turn terrain into an ally. In minutes, the detection planning deployment crossing cycle can complete even under light fire. The result? NATO can preserve maneuver tempo even when fixed bridges are destroyed. In practical terms, 8 M3 modules can form a bridge longer than 100 meters, allowing a 70-ton convoy to cross. Yet the system's real power lies not in steel but in coordination. Unmanned aerial vehicles supply real-time imagery, electronic warfare blinds, radar, and C2 software computes the safest crossing point. The whole network acts as a single organism. Still, limits remain. In heavy ice, in strong currents, or under severe jamming, performance degrades. The system depends on logistics, fuel, spares, and accurate intelligence. A software fault or interrupted communications can slow the entire operational chain. Moreover, excessive faith in mobility risks creating more hotspots than the alliance can defend. Those limits do not diminish M3's strategic significance. It does more than enable river crossings, it sustains the tempo of modern war, where speed and flexibility often outweigh raw firepower. And from that speed, a new ethical question rises: who bears responsibility when the decision to cross a river is made by a computer? When a system like the M3 can autonomously find a crossing route, calculate timing, and deploy in under 10 minutes, the question is no longer what it can do, but who controls it. In digital warfare, the line between automation and human decision-making grows dangerously thin. Every order to cross a river is a strategic decision. It opens the way for an entire force, and therefore, a human must remain in the final control loop. This is the human in the loop principle, to ensure that technology serves humanity, not replaces it. But speed itself is a risk. When algorithms make decisions faster than intuition, even minor data errors or electronic interference can trigger unintended outcomes. A falsified signal, a distorted image, or a spoofed GPS coordinate could send a convoy into unsecured territory. For that reason, cyber defense and data verification now form the new front line alongside mechanization. Legally, the M3 represents the frontier of modern warfare. Semi-autonomous, capable of tactical decision-making in real time. It raises a question of accountability. Who bears responsibility if the system acts incorrectly? The government, the manufacturer, or the operator? The answers remain unclear, but these are the questions every alliance must face when speed surpasses traditional control. And when wars are decided by data instead of shells, the true meaning of power and peace will change forever. As the sun sets over the Vistula River, the water flows quietly beneath the folded spans of steel. No explosions, no smoke, only the fading hum of engines and the awareness that something greater is unfolding, the transformation of what power means. The M3 is not a weapon of destruction, but a tool of redefinition. It proves that in the 21st century, speed, data, and connectivity outweigh isolated firepower. The agreement between Germany and the United Kingdom forged more than a bridge, it built a symbol. A bridge between industry and strategy, hardware and software, nation and alliance. Each deployed M3 module is a declaration that Europe is no longer confined by geography and NATO no longer deters through might alone, but through intelligent mobility. The implications of the M3 reach far beyond the battlefield. Autonomous bridging, hydrological sensors, and distributed command networks hold potential for civilian use, disaster relief, infrastructure protection, and rapid response logistics. War forces humanity to innovate for survival. Sometimes that same innovation becomes the instrument of peace. The lesson of the M3 is deceptively simple. True strength lies not in how far we can advance, but in knowing when to stop. In a world where data can decide life or death, restraint remains the greatest technology humanity possesses. Real power is not to expand war but to prevent it.